I'd say, yeah, 2 weeks from today. Yeah, today is Monday, yes. Let's say 2 weeks from today, you'll probably have a chapter 1 test. So next Monday, there's a quiz on 1-7. And then next week, we'll wrap up chapter 1. So yeah, probably 2 weeks. Yes, it is October 3rd, yeah. Good. All right, so let's look at the little warm-up here. See if you can solve those first 3, and then we'll talk about number 4 together. But we are still working with solving equations because that's kind of like the backbone of algebra. Isolating a variable really is like the foundation building block of algebra 1, algebra 2, and you get a variable by itself. It kind of expands into different forms of equation. So see if you can do those first 3 problems. In your packet, section 1-6. In your notes. Take out your earbuds, please. Section 1-6. Did you get it in your worksheet from Thursday? Your quizzes are graded and were entered into PowerSchool. So you can at least see the score that you received. Probably get them back to you on Wednesday. I just need some more students to make them up. Hey Jay, what would you do for number 1?
Divided by 12.5 on both sides.
And this question here looks a lot like the formula we used last week for distance. It has that r in it, which could be rate, it could be anything really. But if you take 180 and divide it by 12.5, what did you get, AJ?
62.4.
Yeah, 62.4. So opposite of multiplication is division. Anytime a number is written next to something, it's multiplication. So you're not adding because there's not a plus sign in between. That's a multiplication, implied to be multiplication. The next one, Gavin, what would you do for number 2?
Subtract
100 and say it again.
23.
Try it again. 178 minus 25. 153, yeah. And then when you divide by 9, what do you get there?
17.
Yeah, it actually works out nicely. You get 17. And then number 3 has some G's in it, and we also have parentheses here. I'm sorry, Reagan, what would you do? Yeah, what do you get when you take 28 times 18? I'm sorry, say it again. 504, yeah. And then 28 and negative G make? Right, negative 28. Just be careful with that sign there. A lot of students are having problems with that extra negative sign. Make sure you bring down that 28 and negative G, negative 28G. And then, Reagan, looking at the right, if we can just combine those like terms, what do you get when you combine the G's together? Right. Remember, when they're on the same side, you're not moving anything. You're just combining them as they are listed. So it's a 40 minus 28. And then, Reagan, if we continue to solve, what would you do next? And then finally?
And then divide it and get G is 11.
Nice job. Divide by 12 and you get G is 11. Nice job. So, hopefully you were like 3 for 3 or 2 for 3 and maybe you made a little mistake there with those 3 problems. Are there questions on those 3? So if you look at number 4, I said we would do this one together. It says a balloon is released from a height of 5 feet. So let's say I'm holding a balloon and I let it go. So I'm holding it at 5 feet and then I'm letting it go in the air. Its altitude after t minutes is given by the expression 5 plus 82 times time. So the 5 is because that's where it's starting. And then the 82 is how fast it's rising for every minute. So it says, what is the altitude of the balloon after 6 minutes? Daniel, how would you solve that?
So what I do is I multiply 82 by 6. Then after I did that, I add the 5.
Yeah, do you know what 82 times 6 is?
I got 192.
And what do you get when you add 5 to that?
Not 192, 492. I'm sorry.
That's all right, no worries.
And then I got 497.
Yeah. And that is in feet. What is altitude, Daniel? What's another word we could use for altitude? Begins with an H.
Height.
Yeah, height. So altitude is how high something is. It's the height from the ground. So our balloon, only after 6 minutes, is 497 feet from the ground. And again, that was starting at a height of 5 feet, or an altitude of 5 feet. So that balloon is traveling pretty quickly up in the air. All right, so we're going to look at some different types of applications today. And we're going to talk about having a verbal model versus an algebraic model. So the verbal model would be, of course, using words. We'll say using math, operations, and words. So sometimes it helps to like write out what you're trying to find instead of always relying on variables. What do the variables mean? And using words and like some math operations, adding, subtracting, multiplying, dividing. Sometimes it helps just to kind of see things verbally before you place the algebra in it. The algebraic model, in that case, we're using symbols and variables. So instead of saying I'm adding something, we would show that we have a plus. Or instead of saying you're taking the sum of, we would use a plus. Or a minus if it had the word difference. And of course, for the make it algebraic, we have the variables in it. So the first type of problem we're going to use or approach would be a formula type of problem. And they're going to be formulas that we just discussed in the previous section. But here we have a bus travels an average rate of 55 miles an hour. Buses usually, because they're a little bigger, they don't quite travel as fast as a car might. It says the distance between Chicago and San Francisco is 2,130 miles. How many hours of driving will it take for the bus to travel from Chicago to San Francisco? Who remembers the formula that we can use for this, Chloe? Right. So D equals R times T. Why'd you pick that formula, Chloe? Yeah, it's talking about distance. It's talking about time for hours. And it says, how long will it take? Well, that means I want to find the rate. So our formula, distance equals rate times time. So we could verbally say that this is the distance, we have the rate, we have the time. So Chloe, after you know what formula to use, what would you do next? Yeah, what would you plug in? Good. And then we don't know T because how long does it take? So I know how fast we're going. We know the rate is R, and we know the distance is that 2,130 miles. That's a long trip from Chicago to San Francisco. So in this case, you're multiplying R and T together. So Chloe, to get T by itself, you would divide both sides, right, by 55. So Chloe, what do you get for time? How long does it take? 30, oh, 38 hours, sorry.
It's like 38.7.
All right, we'll say 38.7. So about 38.7, and then she said hours. Anybody interested in taking a bus trip that's almost 39 hours long? Yes, really? Why not? Do they still have the mega bus that's like $1? Yes, you know what I'm talking about. It's $1 per mile or something like that. I don't know how that works. Something like that, yeah. But I don't know. I'm not sure I could be on a bus then.
What's $1 a mile?
Something like that, yeah.
You'd be spending $2,000.
Maybe it's true. Maybe it's a little less then. It's $1 for something. $1 100 miles? I don't know. I'd have to look it up. It's the mega bus. Look it up. There you go. All right, so that problem there uses the distance formula. If you look at the next example, also trying to talk about the distance, but this time it says you're driving between Boston, Massachusetts, and Cleveland, which is 660, so not as bad, still kind of far. The trip is 12 and a half hours long. Find your driving speed or your average speed. So see if you can use the formula to figure out how fast you would be going. Has anybody been to Boston? Yes? I've heard it's nice. I've not gone. So anytime you see distance, especially if it talks about speed, if it has time, that's when we want to use that distance equals rate times time. So Jack, what can we plug in for distance? How far did we travel?
660 miles.
And do we know a rate?
No.
But we know
The
the,
total number of hours.
yeah, how long?
12 and a half hours.
Right, 12 and a half hours. So again, this is times. And you still have to perform the opposite operation. So if you are multiplying, the opposite is dividing. So Jack, when you take 660 divided by 12.5, what do you get for our speed?
52.8.
52.8. And then we would label that as miles per hour. So it doesn't seem like you're going that fast, but you figure not everything is on a highway when you're driving. And once you get off the highway, the speed does change. So that's your average speed for the whole trip. And some of you might have a vehicle that actually shows you what your average speed was for the trip as well. Some of them calculate that on the little digital dashboard that they have. Any questions? Yeah.
So I tried looking it up. It doesn't say, it just says express for $1 plus a reservation fee of 50 cents.
Oh. But it doesn't say $1 for what?
I don't know.
But you're right. If we were traveling, that would be a lot. You might as well fly, right?
Yeah.
Because that's a lot of money. So $1, I wonder if it's like $1 per something. I know it's supposed to be a good deal. So maybe it's better than $1 a mile. All right, so the next type of problem we have is an airplane problem. And this is talking about an airplane descending. So you've been up in the air for a while, and then the pilot gets on and says, we're going to begin our descent. We'll be in Pittsburgh in 20 minutes or 30 minutes, depending on how long it takes to descend. But it wants us to use the table to see if we can try and find a pattern. And this plane is at 36,000 feet, which is very typical when you're flying. The pilot gets on a couple of times and they say, like, we've reached our flying altitude. Generally, you're around that 36,000 feet level when you're flying a fair distance. So I went to Florida this summer and we might have been like 35,000 feet. But usually when you're in the air, you're flying pretty darn high up there. That's like 7 miles up in the sky. That's how far you are. So this one wants us to see if we can decide what the pattern is to be able to answer the question. Now, we're not going to just extend the table. So we're going to try and use the information to write an equation, because that's what this section is about. Can we create an equation? Daniel, do you see a pattern that's happening with this table?
It subtracts 3,200, I think, every minute.
Yeah. So that would be kind of looking to see what's going on each minute. Notice the time is going up a minute each time. And then you're looking to see what's happening with the pattern of the y values. And he says you're subtracting, you said 3,200, right?
Yeah.
And that pattern should be the same each minute. So each time from 1 minute to the next, we're subtracting 3,200 feet. So we're going to try and write an equation. And to write our equation, we are going to have, I'm going to write a little verbal model. So our end height equals the initial, and I'm going to use that word, altitude. And then it's going to either be a plus or a minus, and that's going to depend on, am I taking off or am I landing? And we'll use the pattern to help us get that. And then it's our rate times the time. And the rate is going to be the pattern in our problem. So this is called a verbal model. My end height is equal to where I started. You're either adding or subtracting depending if I'm rising or falling. That rate or pattern times the time. So Daniel, what is the initial height in this problem?
3,600, not 3,600,
36,000. So I'm going to use an H for height, my end height. And then you said we were decreasing 3,200, and then you said each minute. And because that minute can continue on, that's where I'm going to put our variable t to represent time. So we have a t here to make it an equation. Remember, in equation, we have to have some kind of variable that we can then plug in for. And t we always use for time. So now, if we want to answer the question, what's the altitude after 8 minutes? This is now like the balloon problem. The balloon problem was going up because the balloon rises. The airplane is going down. And Daniel, what number would you plug in for t?
8.
Yeah, so you have 36,000 minus 3,200 times 8. So very similar to the balloon problem, but we created the equation ourselves this time. And that equation starts with the initial height and then your rate. All right, so we have 36,000. Daniel, 3,200 times 8 is?
I got 25,600.
Yep, and then when you actually subtract them, what is that end height?
10,400.
Right, 10,400, and then that's feet. So by looking at the table, we can kind of model an equation from the table. And again, we still want that equation. So we're not just going to expand the table and kind of keep writing out various numbers. Our goal here is to make an algebraic model or equation. So now, after only 8 minutes, the plane is now at 10,400 feet, which is like 2 miles in the air. So 1 mile is 5,280 feet. So that's about 2 miles in the air still. At that point, the pilot's probably starting to pull on the brakes a little bit so that it can kind of come down at a slower rate. So if we look at the next page, lots of different options here. The goal is to show you different ways to approach problems. So we can use a formula. We can try and look at a pattern if we're given a table. And in example 3, it says, hey, you can draw a picture as well. Sometimes a picture helps explain a whole bunch of things. And this one in example 3 is saying that you're going to paint your bedroom. You want to paint 5 1-foot wide vertical stripes on a wall. Sounds like that would be pretty tricky because you have to make sure they're straight and they're not crooked. Everything needs to be measured just right so it's all equal and you don't have a wide stripe and a little stripe next to each other. There is to be an equal amount of space between the ends of the wall and the stripes, and between each pair of stripes. That's a lot. But everything needs to be equally spaced. The wall is 14 feet long. How far apart should the stripes be? Does anybody ever try to put stripes in your room, whether they're vertical or horizontal? No, it's a lot of planning. It's like you need to know how long the wall is, and then you really do want everything to be very equally spaced. Otherwise, it'll look a little odd. Which, hey, if you're all right with it looking off, that's fine. So we're going to draw a diagram, and we're going to make a wall. So make yourself a rectangle wall. Of course, our wall is only a one-dimension wall here. But that rectangle is going to represent our wall. A beautiful wall. Reese, how many stripes do we want to paint on our wall? 5. So we want to paint 5 stripes. And I'm going to try and make my 5 stripes as equal as possible. So there's 1 stripe, 2, 3, 4. Oh, I didn't do a bad job. So I have beautiful green stripes on my wall. I got 5 of them. It also says that there is to be an equal amount of space between the ends of the wall, so this space here, and between each stripe. And the wall is 14 feet long. I'm going to label my wall as 14 feet so that I know that that entire wall is 14 feet, which is a decent sized wall. This is definitely bigger in here. Each one of those squares represents a foot. So this is more than 14 feet, but still 14 is pretty good. Do we know what the space is between each of the stripes? No. So generally in math, when you don't know what something is supposed to be, you label it with a variable. That's why variables exist. I don't know what it's supposed to be, so we're going to label it with a variable. Each one of these needs to be the same. So I can call them all X because each space is the same amount of space. So I don't know what that space needs to be, but it all has to be the same. So that's when you say, all right, we're just going to let it be a variable X. So Reese, if you now look at the diagram, how many X's do you see? 6. So I'm going to write 6 because there are 6 X's, 6X. How many stripes did you say they were, Reese? 5. And Reese, how long is our wall? 14 feet. So the diagram can be set up like a little equation. I have 6 X values, I have 5 stripes, and together they equal the distance of my wall, which is 14 feet. So our little picture now can be translated to an algebraic form. And then, Reese, to solve for X, you would? What is 14 minus 5? Yeah, and then what would you do? And because this is an actual word problem, Reese, what do you get as a decimal when you divide there? 1.5. So the question says, how far apart should the stripes be? Well, they should be 1.5 feet apart. So now my wall isn't going to look wonky because one stripe isn't closer to the other. Each one of those foot-long or foot-wide stripes will be then 1.5 feet apart so that everything looks nice and organized. Questions? So we are going to skip extra example 3 and we're going to do one final example, which is at the bottom of the page. See if you can read through and try and set this example up. Your aunt is giving you $195. She's not charging you interest. Remember, we talked about interest being extra money that you have to pay. But she does want you to repay her as soon as possible. You can afford to pay her $15 a week. So it says use the problem solving plan to find out how long it would take to repay your aunt. Try and write an equation, so that's the goal here. Can we write an equation to represent the situation? So try and think of what the equation would look like and then we'll solve that equation. But our goal is to come up with a variable somewhere in. That's the algebra part. Okay?
Sorry.
I know, that is pretty darn good. I thought mine were pretty good too, but that is good. Oh, yours look really good too. There's some nice stripes. So, Mackenzie, we want to try and write an equation. What did you write for your equation?
195 equals 15 times t.
Yeah, nice. 15 times t. T for time, t for weeks. You could have used an X, you could have used a W. Your total amount, 15 every week. And again, we want an equation here. And then, Mackenzie, what'd you do to solve?
Divided 15 by
And how much time is it going to take you to repay your aunt?
13 weeks.
Right, 13 weeks. Any questions? So we saw 4 different ways to solve a problem. And that would be by using a formula. We used a pattern. We drew a picture. And this one here is kind of just like writing exactly what we read through the problem. Did I get too many? I'm sorry. So I would like to go over number 2. I want to start number 2 with you. If you want to read through number 2, because number 1 is just distance equals rate times time, and we did a couple of those already. So read through number 2, and let's see if we can try and write an equation to give us that information. So number 2, you buy a used car and are to determine your monthly costs. Your monthly car payment is going to be $252, and your car insurance costs $684 every 6 months. Part A says write a verbal model for the monthly car expense. So I'm going to start off with the word expense. You could say car expense if you want to say car expense, but that's what we're trying to write. What are our car expenses? So if I want to determine how much I'm paying every month for a car, there's 2 things that's happening here. There's a monthly car payment, and then there's also insurance. So our car expenses are going to be our car payment and the insurance. Obviously, you'd have gas as well, but those would be the bills that you must pay first. So you have to pay car insurance, you have to pay your car payment. Those are 2 things that you must pay. Part B says use the verbal model to write an algebraic model. So I'm gonna use E for the car expense. Kenny, what is our monthly payment for our car?
$252.
$252. And then Kenny, in addition to that, it says we are paying $684 every 6 months. So if I wanted to figure out a monthly cost, what could you do with that, Kenny? $684 every 6 months. How could I figure out how much it would be for 1 month, Kenny?
Divide by 6.
Yeah, so we're gonna take that 684 and divide it by 6. So this would be my algebraic model. So my car payment, my insurance isn't $684 a month. It's every 6 months that I'm paying that. So I have to take that amount and divide it by 6. So if I want to figure out the money that I'm paying, Kenny, can you take 684 divided by 6?
$114.
Yeah. And then Kenny, if we add those together, how much is our car expenses for the month?
$366.
Nice job. 366 bucks. So every month for my car, my payment and my insurance is 366 bucks. See if you can answer part C then. You have $450 budgeted for your car expenses.
Have a nice day.
You too. How much money will you have to buy gas? Because I mean, obviously you need money left over to get gas. And right now, gas is still kind of pricey. So there are 2 problems on the front of this worksheet and 2 problems on the back. And you pretty much already have number 2 done. And I guess there's a couple parts to each problem. But some of the parts just ask you to write a verbal model. So you're trying to just write the words to see how you would set up the equation. And then there's that extra part where you want to answer the question. So like answering part C or plugging in how high something is. And you have a few minutes remaining here, about 5 minutes left.